Hello everyone, how are you? I'm hoping you guys are doing great, and from this lecture we are going to discuss about sorting, different kind of algorithms, and how we can perform sorting using Numpy array. Right? We are going to discuss about different sorting techniques like quick sort, heap sort, merge sort, time sort. Okay, which is going to be which are going to have different kind of complexity like n square, n log n, or whatever they are having. So that is not the part of this particular session, that how these algorithm works, but we are going to discuss how to perform these algorithms on nothing but a particular using numpy array on a list. So for that purpose I have created one more Google Colab. So let's import numpy as np really quickly, and let's create an array. This time multi-dimensional array we are going to create, np.array, and in this particular array I'm going to now writing the elements in shuffled order. Okay, so I'm writing 5 elements here and 5 elements here and 5 elements here. Okay, so let's make this whole array of 2 dimensions, and let's save it into an element named as ARR, which is nothing but the array. So let's display it, and this is something that we are getting now, an array of size 3 by 5. Okay, now what is going to be the approach now? We are going to sort this array in different kind of formats. Okay, so let's see how we can sort this array. To sort this array we are having a function named as np.sort. Okay, so how to perform the sort function? So let's write np.sort first of all, and after that let's see what are the different operations that we are having in numpy sort. So from here you can read the documentation. This plays a very important role. First of all, what I can define a, which is nothing but the array which I want to sort. After that I can apply access. Okay, access is nothing but like if I want to I would say sort them in row wise or column wise. Okay, and after that I am having, okay, after that we are also having kind is nothing but means which kind of algorithm you want to apply. Like here you can see we are having quick sort, merge sort, heap sort, stable sort. Okay, and after that we are also having something called as order, string or list of optional when a list is an array with the field defined. Okay, so that is something that we can neglect for this particular time, but you can go through the documentation to know more about it, because I'm just going to tell you which are the most important things that we are having in numpy array. So here the first element is obviously going to be the array that we are having. Array is ARR, and after that I am defining the access. I am defining to 1. Okay, 1 is used to sort the array row wise. Okay, and after that 0 is for column wise. So let's see if that works or not. After that we are having the which kind of algorithm we want to apply here. So I'm applying merge sort for this particular time, and see how the merge sort works. Merge sort is having a complexity, worst case complexity I would say, of n log n. Okay, so let's perform that now. Okay, so let's execute this and let's see what we are getting. So after performing merge sort, this is something that we are getting. What is this? So these are all the elements in sorted order row wise, because access is 1, so we are sorting them row wise. So earlier you can see the elements are 7, 3, 8, 6, 4. These are the elements which are earlier, but now the elements are 3, 4, 6, 7, 8 sorted order. 7, 2, 9, 8, 6 earlier, now 2, 6, 7, 8, 9 sorted earlier. 5, 4, 2, 3, 1, now 1, 2, 3, 4, 5 sorted. So this is how we can sort the elements row wise. So let's see how we can sort the element column wise as well. For that purpose, access is going to be 0, kind is going to be the merge sort only, because we are performing merge sort. Okay, so let's execute this, and here you can see now all the elements are sorted row or column wise. So the first column earlier is 3 to 1, now it is 5, 7, 7, because the elements are in the same order only. Okay, this is my original array earlier, 7, 5, 5. I am performing on this. So earlier 7, 7, 5, now 577 because 5 has the top, 7 7 are going to be the same, so we are going to sort them accordingly whatever we are writing. Earlier it is 324, now it is 234, 892 289, 683 368, 461 146. So this is how we have sorted them using merge sort. If you want to sort them using different algorithm, you can go for that as well. Means if you are going for quick sort, which is having a worst case complexity of n square, you can go for that as well. But comparatively in most of the cases, heap, merge and time sort, tim sort works better as compared to quick sort because it is having less worst case complexity. Okay, so that's up to you which algorithm you are using. But basically what we have discussed how to apply merge sort on an algorithm. Okay, what else we are having? Okay, we have discussed about all things like if I am not defining axis, what will happen? Let's discuss that as well. Okay, so this is the NP array. Let's suppose if I have not defined axis, what will happen? Let's execute this. And from here you can see if you have not defined any axis, then what will happen? It will sort them in row wise. If it will sort them row wise if you have not defined anything. If you are defining anything, that will depend upon you if you want to go for row wise or column wise. If you just want to go for row wise, you do not need to define any axis as well. All you need to define is just an algorithm which you want to apply on your array. So that's pretty much it. Let's summarize whatever we have discussed so far. So what we have done, we have first of all created a Numpy array. After creating that Numpy array, we have displayed it. We have discussed how to apply the sorting algorithms on it. For that purpose, we have used merge sort with axis 1. Axis 1 works when we want to sort the element row wise. Even if you are not writing anything, axis is going to be 1. Now, what if I want to sort the elements column wise? For that purpose, we are using the same thing, which is np.sort array axis equals to 0 kind merge sort, which is going to be the same. And at the end, we are sorting the element without anything, and it will sort row wise. So that's pretty much it about this particular video. If you are having any doubt about sorting the things, you can ask us in the discussion. If you want to dig deeper into how merge sort, quick sort, heap sort, all these sorting algorithms work, we are having another channel. You can go for that. You can search about GeeksforGeeks for that. So you will get to know about all the algorithms for that. Okay, so that's pretty much it. If you guys are still having any doubt on this, you can ask us in the discussion or comment box. Otherwise, I'll see you in the next talk with the new programs. Take care then.